Good day. We are going to carry on from the previous examples, and we're looking at more complicated questions where we're going to have to use a bit of algebra. And unfortunately, this question is not going to involve making a perfect square, and it leaves us no choice but to use the quadratic equation. So we look at this question and reading becomes really important. So we're given an equilibrium constant. We're given an initial concentration. We need to have an equation, a KQ expression, the usual stuff. So here's our reaction. Now we can plug in what we know. And all we know is the PCl5, what we're starting with. On the left, it's a minus x because to get the equilibrium, we're shifting right. And we're going to use up some of this, and we're going to gain. And you go, oh, isn't that nice? Minus x plus x plus x. So at equilibrium, we're going to have our 1 minus x on the left and x on the right. And that's what we're going to care about on our next page. That's what we're going to be plugging into our KQ expression. So there's our KQ expression. And now we've taken the equilibrium information. We had x times x, so it's x squared over 1.00 minus x, and we're told that equals 0.0211. Now, unfortunately, we can't do our little square root trick. This part's squared, but this is not a nice perfect square. So we have no choice. We're going to have to expand things out, and that's what we do. So we take this number, multiply by the 1.00 minus x, and it equals x squared. And, oops, I better give you some time to look at that. So when we get there, we have an x squared. We have 0.0211 times minus x. And so when it crosses to get to the same side, it becomes plus 0.0211x. And then we had this being a minus plus 0.0211, and it came the other side, became a minus. Now, if you have a graphing calculator, you're lucky. You just have to get this far, and you can use the graphing calculator to get your zeros, as they say. But on the next slide, I'm going to show you what happens if you're like me, don't have a graphing calculator, and have to use the quadratic equation. So we're going to plug in those coefficients, boom, boom, boom. It's all from the previous slide. And we see we're going to get this, and we're going to have to simplify the mess inside. So that's what we're going to do next. And now we have to decide which number is going to make sense. So we have a 0.135 or a minus 0.156. Well, you probably have a pretty good idea that we can't use that. Can't have a negative concentration in this game. So we know our x equals 0.135. Now we have to go back to the original question. What did it want to know? It wanted to know about the Cl2 concentration, which happened to equal x from equilibrium. So it is indeed the 0.135, big M. So believe it or not, that's one of the toughest questions until we get to the next video, where I think it's even a little more exciting.